Okay, welcome everybody to the last topic of the year. And this topic just reminds me that it's been a journey and we can see the end. You know, when you're traveling and you see 10 kilometers, then you see 9 kilometers. Yeah, that is where we are right now. We're about 5 kilometers away to the end of the road, which then brings us to active revision. Okay, now this topic is about counting and it's linked to probability. So just to remind you of something, I'm not doing the grade 11 one now, okay? We'll see what we are able to do. But just to remind you that probability is the chance of an event occurring. That's very important. So let's just take it from there quickly to say the probability is what? A chance of an event occurring. All right? And we know that probability of an event will be what? The number of possible occurrence of that event divided by the number of total what? Outcomes. We know that, right? That we know from grade 8 or something. That probability of an event is the number of times that event will happen over the entire sample space. Just basic. What's the probability of choosing someone out of a class of 15? It's 1 over 15, straightforward. All right? The probability of the chance over the number of total outcomes. Okay. And then we know that for complementary events, which is what we have in most cases, the probability that an event will happen plus the probability that the event will not happen is 1. That's very important. The probability that it will rain is 0,2. So the probability that it will not rain would be what? 0,8. It's either or not. Okay, so that's very important. Okay, from there I stop on probability because we're going to need this along the way. We talk about counting principle. Very interesting counting principle. We're talking about the number of ways an event can occur. The number of ways and given different restrictions. Such as repetition or not, together or not, you'll start seeing them, and so on. You'll start seeing there'll be restrictions now. Number of ways an event can occur. Let's make it very simple. Very, very simple. We don't want to make it complicated. Example. Consider the letter A, B, C. So it's not a word. So please don't bring English here. It's not a word. A, B, C. In how many ways can we arrange this? Consider A, B, C and arrange the letters in all possible ways. Arrange the letters in all possible ways. Let's look at this together. 5. Okay, let's start by saying, let's start with ABC itself. That's an arrangement.
Yeah.
Right? That's an arrangement on its own. Yes? Do I have someone talking to me there? Tando way to 9. Okay. Let's see, Tando. Let's see if you're correct. Let's go very basic, normal. ABC. I could keep my A and change the B and C. Aisha Mel. That's one other arrangement. So I kept the A and moved the B and C around. Okay. Now let's put the B in front. Now I can switch the A and C around. We can now start with the C and switch the A and B around. And I promise you, you cannot see any other arrangement from here. Let's see. Try. If you can find another arrangement that doesn't exist here already, I'll give you 500 Rand now. Just send your account details and I'll EFT. If you can find another. I don't know. I want to see, guys. Is there any other way? Give me a thumbs up if you find something. Give me a thumbs down if there's nothing. Is there another way that you see? When the math teacher throws money like that, you must know that just the answer is no. So how many ways? 6. Lovely. So there are 6 unique arrangements here. Now the question is, if I have more than a 3-letter word, am I going to do the same?
Yeah, you can. No, you can't.
If I'm in an example, okay, a word like Mississippi, when will I finish?
Yeah.
A word like Limpopo, Macedonia, Hula Baloo, I mean, pandemonium, then it's really going to be a pandemonium. So mathematically, this is just to show us something, but mathematically we can have a way of doing this, and that's the beauty of this. Mathematically, let's find a way of doing this. It's the number of events. Now, please look at the principle. Once you get this principle, we're going to start changing a lot of things. What is the principle of counting? Counting principle is the number of options. Or let me say, sorry, I know you're writing. It's the product. I want us to put that word. It's the product of the number of options. And I'll try to make this easy. Then I'll try to give you something to summarize. Product of the number of options of each event. Of each event. Let's look at this one so that we can, I want us to trust the mathematical process. Okay. So, I had ABC, right? This is what we do. We have 3 events here. Event 1, event 2, event 3. I have ABC without restriction. How many letters do you think can fit into the first option? It's either A, B, or C. So there are 3 of them. Please let me know if you understand that 3. I have 3 options that can sit in that place. It's either I put my A, it's either I put my B, or it's either I put what? A C.
Okay. No.
Right? And I'm using the word and in probability. And is always what? Multiplication, or is addition, right? And now, if I use A in the first option, I have two left. It's either B or C. So I have two options. But because it is and, because it's a letter, it's a full word. Now, if I use A, I have used A, which I cannot use again, per round. I have used B, which I cannot use again per round. How many options do I have left? One. And what's your answer? 6. And that's the maths behind it. And we are done with the topic. Yeah, but when I say that's it, you should know that now they are going to tell you B must not be next to C and A must, then start. But but that is the basic story behind. I don't know if it makes sense.
Yeah, it makes sense.
In how many ways can 4 people be seated? So, in sitting 4 people, and check, I have 4 chairs. I cannot repeat a person because we're going to get to repetitions very soon. But I want us to get the whole idea. I cannot repeat. So the first seat, it could be any of the 4. Second seat, now I have any of the 3 that are still standing. How many people are standing now? 2. Any of the 2 can sit here. Duh, you're the only one left with a chair, without a chair. And what will your answer be? 24. Are we okay, everybody? It is that simple, but then remember, we are going to start creating a lot of restrictions now. To say, look, I want 4 people to sit down, but there's this couple, they won't listen if they sit together. I want to make sure the seats, let's arrange them in such a way that A and B don't sit together.
No, but then don't you reduce that? So instead of being 3, it becomes 2, and then the third seat becomes 3.
Okay, we'll see just now. It starts. I love it. Your head is you're starting to roll things around in your head. Okay, look at this word. Let's look at another example before I start giving you scenarios on how to work things out. Consider. Let me do it on a fresh page, on a fresh side. Consider the word, how do you spell air? To air is human. E-E-R, right?
To what?
To air is human, to forgive is divine.
To what is human?
To air.
To air?
Yeah, E-E-R or E-R-E. Check. Really? You've never heard it before? Now I'm missing it. Is it E-R? Just check E-R-E on your phone there. E-R-E or E-E-R. To err is human, to forgive is divine. Once you type it, the phone will tell you. It's E-R-E.
The word E-E-R is somewhat old-fashioned, forever or always.
Okay, it's fine. Whether E-E-R or what, we're just creating. It's not English. Don't worry. E-E-R. Okay, check this. Now, consider the word E-E-R. I want us to look at this. Let's put E1, E2 to create a difference for now. Okay, let's rearrange it again. Can we keep E1? It's actually E-R-E. This is the correct one. To A is human. All right, so this is E2. Please watch this. Now let's keep E2 here. What do we have? E1 and R. I'm just trying to show you the kind of restrictions they're going to put in place. Look at this. E2, R, E1. And then I could have what? R, E1, E2, R, just similar to the ABC. Okay, so we have 6. Only if the E's are different. But now, if I tell you that there is no difference with this E, what do you notice? Yes, because I'm having repeated words. Okay, which ones? I have E-E-R. I have E-R-E. We're going to cancel the one that is repeated. E-R is repeated. E-R-E, repeated. Do we have REE? So how many unique letters do we have? 3 arrangements. So these are things we need to now learn how to do. But the basic thing is to remember options. It's all about what? Options. Multiplying the option of each event. Are we okay? All right. Now let's go to some mathematics now. This is all English. Okay. I'll start by giving you a few things. Key points that I need us to note. Number 1. Arranging n items, n means number, right? Uniquely. Arranging n items uniquely such that none of the items can be repeated. Just like the ones we did, right? E.g., number of people in a class, like that, you know, something you cannot repeat. A set of letters where there's no repetition. We said ABC. They don't have anything in common. Answer would be n exclamation. And it's not an exclamation. That exclamation is known as a factorial. And I want to quickly explain what it means so that you see. We've used it today, but you don't know. N factorial is n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3, and that will continue until 1. N factorial is n multiplied by, so just keep dropping the number. For example, what is 4 factorial? It is 4. What is 4 minus 1? 3. What is 4 minus 2? 2. 4 minus 1, and then you stop at 1. What is 5 factorial? 5 times 4 times 3. Now get your calculator. That factorial button is there. Get your calculator. We'll look for that factorial button. You would see that factorial button on your x to the power of negative 1. It's a yellow. It's written in yellow. Top right corner, you have your on, you have your log. Beside your log, you have x to the power of negative 1. And on top of it, you have x factorial. So look at it. 4 factorial. You must please let me know if you all find it. 4 factorial. Everyone should please find it. Find it. If you don't have it on your calculator, please just stand up, go to your kitchen, put on the stove, leave the calculator on the stove, and come back to class. I'm serious. If it's not there on your calculator, just follow the instructions. Just quickly excuse yourself, run to the kitchen, put on the stove, put the stove at the highest, and walk back to class. Yes, talk to me. Motlali Pule, talk to me. Oh, Teslima, you actually answered me. Yes, you're correct. It's ERR. To air is human. Oh, my English. Motlali Pule, talk to me. Your hand is raised. And if I press equals to give you the 24. This is 2 marks, sometimes 1 mark. And in most cases, the first question. I'm not saying in all cases, in most cases, 5 people are standing. How many ways can 5 people be seated? 5 factorial. Because basically 5 times 4, it's options. All right. By the way, there was a year where this came out in algebra.
Sure. What? The proof?
No. We're given a factorial question in algebra. But I'll find it for you. Please start again. Say, I just went to fetch my calculator. Oh, my. Google, did you put the calculator on the stove? Did you put it on the stove? No. Okay, Google. Don't worry, we'll get you. So we're saying factorial is simply, and that's why you need to know the simplification of factorial. Just I can't remember the year, but I remember the question. So factorial is used when you multiply in descending order, but it must get to 1. All right? So if I say 6 factorial, look, 6 factorial, I know 6 factorial should give me 720. That's a lot of options. All right? And that is basically saying 6 times 5 times 4 times 3 times 2 times 1. 720. We're going to get to a place where we use 10 factorial. I used to know this number off by heart. 362, yeah. And basically that is what? 10 times. Let's prove it so that everybody gets to see that. So it's 10 times. You remember the number, right?
Yeah.
Times. I know you don't remember, but you have an idea what it looks like. Yeah, 3 8 something. Times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And that will give you that. Okay. The question is, when do we use factorial? I can only, please, I'm going to take you slowly. If I don't finish today, I'll come back next day. We use factorial when we have to arrange n items uniquely. I have 5 people and I have 5 chairs. Okay? I want to introduce another letter to you. Arranging n items uniquely such that there is none of the items can be repeated. Can we add this? In R spaces. In this case, n is equal to R, because I'm going to do a situation where n is not equal to R. Please, I want you to follow me. So, how do I put 5 people on 5 chairs? The number of items is what? N. The number of chairs is R. We get that. Which means I can create a situation where I have 4 chairs.
Then n is not equal to 4.
Then I have 5 people. Okay, guys, are we okay with the first one? You will see questions. We'll deal with questions together today. Okay. Number 2. Arranging n items uniquely such that none is repeated again. In R spaces where n is greater than R. Example, how to seat 5 people on 4 chairs. And guys, please, if you understand the issue of the options, I'm going to try to create formulas. But I want us to work basically with just manually options. Now it's going to be easy. It's going to be easy. Please check this. How many chairs do I have? 4. Right? Let's just follow through the process. We have 4 chairs. How many of these 5 people can sit on the first chair? All of them can sit. Make sense? 5. So out of 5, 1 is now seated per time. but it could have been any of the 5. If one is seated, how many are standing? 4. How many people can be seated? Remember, we're saying chances of them sitting. So chance here would be what? 4.
Like musical chairs. Like musical chairs.
Huh?
Musical chairs.
Like musical chairs, where, when you're still small, you used to dance around those things. There's punishing people there, And then you have 3, and then you have what? 2. One person must be standing. That one is out of the game. So, this is just multiplication. Don't worry, it doesn't affect now. I'll show you. You know why it's not affecting? Because it's 1.
Yes.
How are you? So what will this still be? This will still be what? Give me an answer.
Now, 5 times 4 is
120.
times 3, yeah.
Okay, 120. This is not affecting. Now watch this. Sit 5 people on, sitting 5 people on 3 chairs. How many chairs do we have? How many options for the first one? 5. Second one? 4. What will this be?
5 times 4 is 20 times 3, 60.
Do you see the effects now? Hello?
Good evening, sir.
Divine.
I wanted to ask a question, right? So I noticed that whenever you're filling the numbers into a space, you always do it in descending order. Is that the rule you have to do it? Or would you be wrong if you say 5 times 3 times 2 times 4?
Okay, we look at this divine. We're looking at options. For example, check here. If I have, let's choose the letter A, B, C, D, E. Okay? Are you with me, Divine?
Yes, sir.
Okay. Now, if I look at the first option, let's clean this again because I want us to do it afresh so that you get it right.
Okay.
The first seat, what options do we have? It could be A, it could be B, it could be C, it could be, because that's the one that has the maximum. No one is seated yet. So that first position can occupy 5. Do we agree?
Yes, we do.
Okay, let's say C is the strong guy. C is now seated. What options do we have left? How many people can sit on the second seat?
4.
Do you see the descending order now?
Yes.
Now, this guy is sitting. How many people can sit next?
3. Oh, okay.
And guys, do you notice I didn't say 5 factorial? Because because I don't have 5 chairs available. I have 5 people. So sitting, arranging n items uniquely to fit in a smaller space. Now mathematically, there's what I can do. But if these formulas are not available on the formula page, they are called permutations. All right, your calculator can do it. But I wanted to learn how to do this manual count, because manual counting would work. It will help us a lot. Yes, because this thing you see, we're still going to fight before the class is over. They were still going to fight. No, it's 5, it's 4, it's 3, and I'll keep quiet. Okay.
Yes.
Molebo, we are all watching TV together now. Girlfriend? Oh my word, this child. Okay. All right, so there are ways of doing this, but I prefer you to know the manual one. It's always quite kind of easy because there will be too many formulas. But I'll be showing you the formulas. We test it as we go on. All right, for this one, if I have to arrange 5 in n places, I could say I'll put my formula in a bubble. Oh no, let's put a yellow bubble. Please don't cram the formula if you are not okay with it. N factorial over n minus r factorial. Looks like n factorial over n minus r factorial. Sn. Check. How many people do I have? 5 in this question, right? Over, and I have 3 chairs. Oh, in bracket, please. Factorial. 60. Can I show you the maths there? Let me show you the maths there. It's very, very basic maths. Everybody look up here. So here's the maths. And it will, because I'm going to give you that algebra question before we finish. So it's 5 factorial over 5 minus 3 factorial. What is 5 factorial? 5 times 4 times 3 times 2 times 1 over 5 minus 3, 2 factorial, which is 2 times 1. Do you notice it leaves us with that 5 times 4 times 3? Make sense? Okay. Are we together, everybody? I'm going to do just a few more concepts, then we answer a few questions, then we continue with some concepts again. All right. So anytime I have to arrange n in R spaces, I can simply use that formula or just do it manually and just ask myself if I have this, I have that. So it's not always n factorial. Okay. Number 3. Arranging n items in n spaces with repetition, or in R spaces with repetition. Let's put R since we want to use R. This would simply be n to the power r. Give a very simple example. I want to arrange A, B, C, D. You see, once I say with repetition, I cannot use human beings. It has to be items, letters per se. I want to create a password. Okay? Such that I can repeat any of these letters, a unique 4-letter password. So I have a 4-letter password. How many options can go into the first one? 4. Now they are saying with repetition, I can repeat. So I could have a password that is A. So it means in the second option, I also have what? 4. Third option, I also have what? 4. Fourth option, so what do I have? 4 times 4 times 4. Basically, do you see it's 4 to the power 4? I hope that makes sense. If it's repetition, I'm allowed to recycle my number of options. That's what we're saying. But remember, it cannot be a human being. It cannot be, let me give you quickly where you would get this. Plate number of a car. Okay, let's try that. Let's try that quickly. Everybody, let's do this. We have cars. Let's create passwords. Let's create password. Everybody, please listen. We want to create a password. How many digits? How many? 5-digit password. 5 digits password. Check. And what's our sample space? We can use A to Z, and we can use 0 to 9. Okay. It's a 5. Let me see. It's a 5 digits. There's a 5 code because digits are numbers. Let's speak the right English. Okay. And this password would contain 3 letters plus 2 numbers. Almost like a number plate. Okay. So With this, we can count the number of cars that has been registered in a province. Okay? Letters. So here, we're starting with letters. They will always give you what to start with, and digits. Okay, number 1, repetition not allowed. Interesting, right? Repetition not allowed. In case you want to rob a bank, please call me. This is what I'm good at. We can work together in cracking the code. Repetition allowed. How do you think I bought my smart board, guys? I'm joking, guys. This is going online. I didn't rob a bank to buy a smart board. Please. Okay. Disclaimer. Because when you upload, they are going to actually search all the things you say, and they'll tell you something found. One restriction found. He stole money. Disclaimer, I didn't. Okay, guys, let's see. Repetition is not allowed. Which means we cannot repeat either a letter or... Okay, so how many letters do we have? 26. Yeah. Which primary school did you go to? 26. 26. But because I cannot repeat, if I have 26, then I'm left with 25. And it's a multiplication. Then I'm left with what? 24. I'm done with the letters. Now, numbers from 0 to 9, how many digits? 10. Because 0 is included now, right? So I'll have what? 10. And I'll have what? 9. And you multiply that out. Okay, don't tell me that number. It's going to be a very big number. That space will not even fit. It's interesting. Making sense. Okay. Repetition allowed. What would this be? 26 times 26 times 26 times 10 times 10. Let me see if we are all on board. It's about the number of possible options per event. You'll see the questions, they just become a little bit tricky now. I want to quickly let me do about 3 more events. Okay, then we jump into some questions quickly. And I want us to see how they will be asking those questions. Okay, and we'll walk through them. Can you see I'm working manually in some things? I want to work manual, then work with formulas. Okay. Can I move to number 4?
So, in those websites, and they tell you you have to use a certain character, a certain amount of numbers in it. That actually is less secure than one where you're free to choose anything. Because then your thing is shorter.
When they ask you to look, because they want to see whether you're not a robot, that's the whole thing. This one is for, it's quite a long, this is statistics basically. This is statistics. Like I said, if you notice number plates are different, what causes the difference? It's because probably a particular pattern has been exhausted. So we can count the number of cars that have been registered without moving an inch. Because we just need to know, okay, how many letters first, how many numbers, numbers repeated. There was a time I started with some learners, I wanted to count how many people wanted to do the statistics of IDs that we have in South Africa. But that one is too crazy because we would have people born on the same day. So we gave up. Okay. But you would see some applications to this. Okay, let's see something here. So that is scenario number 3. Scenario number 4. If a word contains repeated letters, how do we deal with that? For example, we did air, right? The school. The word school has 2 O's, and we want unique letters. Okay, can we go back to, I want us to use manual things that we can do. For example, we said the E, okay, to err is human. Let's get it correctly now. Yeah, that's it. To err is human and to forgive is divine. If we rearrange this, we can have that again. R1, R2, R2, R1. Okay. Then we could have E, no, that's all. What can we have? R, E, R, R1, R2, R, E, R. Oh no, I don't want to mess it up. Let's keep R1 here, R2, E, right? Then if we bring R2 to the front, E, R1, R2, R1, E. Okay, we're good. But we said, they are no longer, if we do this then, they are no longer unique. Right? So the only ones that will be accepted will be this, what did I write here? And which one? This. Right? Because ERR has been counted up, RRE is counted down, and RER. So our answer is what? 3. How do I do this mathematically? Look at what we are going to say. It's going to be, yes, talk to me. There's a hand, quickly. So y is 10. Sisanda, 0 to 9. There are 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Does that make sense? 0 to 9. Yeah, 0 to 9 means we have 10 digits. 1 to 9 and a 0. Okay, lovely. N factorial over repeated factorial. N factorial over repeated factorial. So with these, I'll eliminate what is repeated. Let's try if it works. How many letters do we have? 3, right? So this will be what? How many R's do we have? No, 2. Check your answer. It's 3. So every time I put that division is to eliminate. Look, Limpopo. We're not going to count this manually, please. Never. We won't finish here. We are actually going to get confused. Right? But do you notice I've got 2 P's and 2 O's. So what will it be? 1, 2, 3, 4, 5, 6, 7. It will be what? 7 factorial. How many P's? 2. How many O's? 2. You get an answer, you're done.
0 factorial.
No, did I write 0? But 0 factorial is 1, by the way. Oh, I wrote O. I wanted to write mathematics. What's the answer for the first one? Sorry? 1,002. Do you know why? Because it's 7 letters. It's a long, long thing. 1,260. Mathematics? I think there are 12 letters. 1, 2, 3, 4, 5, 6, 7, 8, 11. We just leave it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. 11 factorial. How many M's? 2. How many A's?
1.
2. How many T's? 2. How many H? 1. E, 1. I think that's all. All right. Give me an answer. It's going to be very long.
4 million.
4 million.
Yeah.
Oh, God. Okay, 4.
4 million. 989,600.
Yeah. You sure, Divine?
Yes.
Okay. Mississippi. MISSISSIPPI. It's a river. The Mississippi River. Chica, you do geography. Okay, fine. Now, thank you. You do geography. I see you do geography. My sai pie. Imagine doing this manually. You can't. But how many do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is it 11? Huh? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? Because there was something I wanted. 11 factorial over. I wanted to see something. So we are having two words that are 11 letters. I want us to see the difference between the two. How many M's? 1. How many I's? 4. S's? 4. P's? Okay. That number is going to be way smaller than 4 million. There'll be too many repeated letters. Somebody give me an answer? And those of you that are not pressing your calculator, you should notice, those of you that are pressing at the denominator, I'm sure you first got an error. If you don't put a multiplication.
34,000.
34,000?
650.
And that's why it's good to work in a class and also practice, because some of you are just copying your secretaries, just writing, and then you get into the exam, then you do this. Then you say 11 factorial over 4 what? Factorial, 4 factorial, and what? 2, and then boom. This guy was lying to us. No, you were not practicing. To figure out, if you're practicing, you'll have figured out, but why am I getting an error? That's why it's important.
So is it illegible to say 4 factorials? It works.
Okay, yeah, but why do you want to make life difficult? 34,650. Okay. I have that question in my head. I'm going to give you. It's an algebra question. It's right here in my head. I can see it. Which year? Which year? Which year? Which year is it? Which year? Which year? Which year? It's a 2020 or 2021 prelims.
I don't doubt it.
How think? I'm going for it. Come. Let's check. Please, let's check. Wait. I think it's 2020. Just 1 second, please. Yes, talk to me. I'm not looking at my screen, so I need you to talk to me right now.
Hello, sir.
Hi.
Sir,
Yes, I'm listening.
I do not understand what you did there by the repeated part.
You divide by the number of repeated letters. So you just...
So why is it 2, sir?
Because there are 2 P's. There are 4 I's, 4 S, and 2 P's. Does that make sense? Mississippi.
Okay,
4
Yes,
I's,
sir.
4 S's, and 2 P's. That's why we divide. Okay. Oh, no. Okay, I'm going to find it. Was it a national paper or... I don't know why they put those funny passwords. I should have actually removed them. Somebody puts Istanbul, but he has not even left Joburg. Istanbul. Everybody just looks at it and say, okay, this Istanbul might be nice. I have to find that question. No, it's not this paper. It's not. I'll find it, guys. But if I don't find it, I know what the question, but I just don't want to write it. Okay, are we okay with what I just explained now? So if you look at this one, it's 2, 2, 2, because I have 2 M's, I have 2 A's, and I have what? 2 T's. But if I look at Mississippi, I have what? 4, what is this?
4
I's. Then I have the S's are also 4, and then 2 P's. We okay there, right?
Yes, sir.
Okay, lovely. Let's go to another event. Event number 5. Event number 5. Items not placed together. No, wait. This one's going to be difficult. Let's start from this. Items placed next to each other. A, B, C. But I want A and B to be together. Or let's use A, B, C, D. Consider, then I'll tell you the secret behind it. But B and C must always be what? Together. It means I cannot separate what? B and C. Okay. Okay, listen to dynamics. Once I cannot separate B and C, B and C becomes one. So, basically, I have 3 things. I have A, B, C, and D. Make sense? Then I have A, D, B, C. Then I have B, C, A, D. Does that make sense? I'm maintaining the fact that B and C are together. Then what do I have left? D, B, C, A, and then D what? Okay. How many arrangements? Hold on. Y times 2. Whatever I have, I can swap them. So for BC, I had 6. For CB, I had, oh, sorry, I see someone's crying there. Don't worry. All you need to do is to count them as one. So check what I'm going to do. Guys, we don't do all of these funny things anymore, right? So here's the system. Count those things that need to be together as what? 1. So if I look at A, B, C, D, how many items do I have? 3. Are we okay? All right. But now, how then do I deal with this? So I have 3 items because this is grouped as 1. In how many ways can these 3 items be arranged? 3 factorial. Yeah. We know that already, right? But then go inside the one that are together. How many items do you have there? 2. In how many ways can they be arranged? I'll give you a formula for this, and this will simply be what? 12. Let me make it clear. Hold on. 7 people are to sit together. No. 7 people are there?
7 people need to sit together, and Mr. Bishop must sit next to Susan.
Yes, I must sit next to Susan. But 3 people must sit next to each other. Very simple, guys. Just watch. I have 7. Let's use A, B, C, D, E, F, G. But I want 3 people to do what? A, B, C, to sit together. So I am counting them as 1. So how many items do I have? 1, 2, 3, 4, 5. And that gives me what? 5 factorial. Then go inside that 1 that you have. How many people are there? 3. I can mix them together. In how many ways? 3 factorial, and we are done. A simple formula would be this, if you would remember. N minus R plus 1 factorial, R factorial. There are 5 people, right? Check this. No, there are 7 people. 3 must be seated together. R is the number of people that must be seated together. What is 7 minus 5? 4. 4 plus 1? 5. But manually, just group them. Because I don't want you to cram the formulas. You'll forget. They are not on the formula page. You'll forget them. So I want 3 people to be seated. So look, you have a... Let's try something. Let's try something. Can we try manually? Because I want everybody to get it. I have 5 books. No, that's going to be hectic. I won't finish. No. I wanted to say, okay, yeah, it's fine. 5 books. We can finish. We can finish. Can we try it? Okay. Ready? I have 5 books. I have a maths book. I have a physics book. I have an accounting book. Okay. 5 books on the shelf. 5 books. We're going to try. I have a maths book. I have a physics book. I have an accounting book. I have the life science book. And I have what? A English book. Mpali. All right. These are my textbooks. But I love my maths and my physics. Or with my accounting. So much. I want to put the 3 of them together. So I get a rubber band and tie them. How many will that be? 1. Does that make sense? So I have MPA as 1 book with a rope. Then I have this one as loose. Watch this. I'm going to start with my maths book throughout. So I'm starting with the maths book. My rope is still there, but I'm changing this once. Right? Now I put the whatever, life science, but I then bring my binded book together, but I'm still starting with what? Maths. Then I have that. I'm still starting with what? Maths. Then what else do we have? E, L, M, P, A. Then what? E, L, no. M, P, A, L, right? M, P, A, L. How many? 6. But remember, I only put the maths book first. I can put the physics book. Yes, talk to me. There's a hand there. This is not all. Yes, Divine?
So may I ask, so in terms of this, can we conclude that there will always be 6 outcomes
No.
in mixed and then you multiply it by the number of letters that are grouped, something like that, but like the 6 that you always keep writing, can we conclude there will always be 6, or does it change?
Divine, it's not always 6. It's just if I had 4, then I wouldn't have 6. If I had 4 books, then I wouldn't have 6. Okay?
Okay.
Yeah, it's just coincidental that it's 6. All right. So this arrangement is only for me to have what? The maths book first. Now I could go into that tied material and rearrange and put what? I'm not going to finish, guys. PAM. And still have what? LE. PAM. I want it's EL, right? Are my books still together? Yes. Then I'll come and say what? L PAM E L E PAM. No, this is punishment. Then I'll have what? What else? E PAM. Then I'll have what? E L. Oh, by the way, are you aware that? Wait, hold on. Even before, don't write this. It's punishment. Just want to do something. Wait, I actually moved too fast. Are you aware that I could still have my maths book first and switch accounting and physics?
Yeah. So, but there's only 6 different ways that you can arrange that.
Now, for each of this, do you notice there are 6? Okay. But why punish ourselves when we can? Guys, there's no time. I have quite a number. So let's group my MPA as what? 1. So how many books do I have? 3. Okay. So my MPA is 1 book. My L and my E. If I move this around, it's 3 factorial. Right? But then inside the MPA, I have 3 books as well.
Yes.
Which is another what? 3 factorial. Which is the same as saying n minus r plus 1 factorial r factorial. How many books do I have? 5 in total. How many must be together? 3 plus 1. Make sense? And what do I have?
5 minus 3 is 2 plus 1 is 3 factorial.
Wait, let me show you some questions. I want us to practicalize this, okay? I'm going to start with baby questions. Look at this. 9 cars of different makes, of which 4 are black, are to be parked in a straight line. Please think about the maths. Don't just jump in. In how many different ways can all the cars be parked?
You can't go black cars as 1.
No. 9 cars of how many cars do we have? 9. In how many ways can all the cars be parked? There are 9 cars, 9 factorial. Done. So number 1, 9 what? No restriction. Then you write the value. Please give me 9 factorial. You see, I have no restriction here. 362,000? 880. No restriction. I have 9 cars. Can be parked in 9 spaces. Now look at, they're going to start throwing restrictions. If the 4 black cars must be parked next to each other. That is, no matter what we do, all the 4 cars must be together. It means we group them as what? As 1. In how many different ways can the cars be parked? Now, your 4 cars alone can be parked in 4 factorial ways if I just have the black cars only. Does that make sense? All right. So, number 2, I will just come and say, how many cars do I have? 9. How many must be parked together? 4. Or I'll show you something else. And what? 4 factorial. Or since I know I have 9, I have 9, right? Let's do something. I'm trying to find, okay, A, B, C, D, E, F, G, H, 1, 2, 3, 4, 5, 6, 7, 8, 9. 4 must be together. Group them. That is 1, 2, 3, 4, 5. Is it 6?
Yeah.
Do you see that? Because I'm grouping those ones as 1. That gives me what? 6 factorial. But then I come into this place. I could have A, B, C, D, A, B, D, C, A, B, blah, 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 blah. 4 factorial, which is the same thing as this. 9 minus 4, 5. Plus 1, 6 factorial, 4 factorial. Give me an answer. So this is what the examiner would be setting. These are the, you see, it's 5 marks. 280. Thank you. Sandy as well. 70,000.
208.
Let's play around with some few questions. I want you to try this for me. It's 3 marks. Try. And then we work together from there. How many 4-character codes can be formed if the first character must be an alphabetical letter and the remaining characters must be digits that may not be repeated? No formula here, normal, just do it normally. Draw 4 spots. It's 4-character codes. Don't do any formula.
18,700.
I have an answer, 18,000?
700.
720, anybody? If the first character must be what? An alphabetical letter. There are some questions they would even tell you don't put vowels. So you must know your English. Yes, anybody wants to help me from home? Someone? Anybody?
Sir?
Yes, talk to me. Michelle.
So I wrote 18,720.
How did you do that? Talk to me.
So,
Yes.
So I created 4 spaces.
Okay.
And then I put 26 in the first space. Then I put 10, 9, 8.
And what's your answer?
18,720.
Guys, for the letters, 1 mark. For the digits, 1 mark. For the final answer, 1 mark. Make sense? Perfectly correct. Yes?
Yes, I have a question. Why didn't you say factorial?
I cannot say factorial because I only have... Factorial is when I have 26 spaces and I have 26 letters. It's about options. Factorial is used when your option goes to 1. I have 4 things and I want to put them in 4 spaces. Then I can say 4 because it is 4, 3, 2, 1. That's when I can use factorial. Come back here, Michelle. Look at this. In how many ways can 9 cars be parked? I have 9 spaces, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. The first option, 9. Second option, 8. Third, 7, 6, 5, 4, 3, 2. Do you see it takes me to 1?
Yes.
That's why in the note I told you when do you use factorial. Let's go back quickly. I use factorial when arranging n items in n spaces.
Oh, okay. Since we only have 1 space for the letters,
So,
say 26.
Now you get it.
Okay.
Now you get it, child. And
Yes.
there are 10 digits, but do you know how many spaces I have? 3.
3 only. Yeah.
Okay, you get it. Thank you. Let's look at this one. 7 marks. Guys, we're already looking at questions. We are done. Ben, Ntlantla, Owen, Derek, and 6 other athletes are to take part in a 100-meter race. Each athlete will be allocated a lane in which to run. The athletic track has 10 lanes. How many people do we have? We have 10 exactly. 4 named and 4 unknown brand. Okay, lovely. In how many ways can all the athletes be allocated a lane? Yes?
So we're always going to have 10 numbers. Or maybe we'll be like start with 20 and go down. Or I'm always just going to start from 10 going down.
How do you mean?
From Brisbane 2018, I see you started at 10 to 10. So I'm asking, is it possible maybe you would like start at like 20 or like 19, or is it always going to be like 10 digits?
Any number.
Okay, thank you, sir.
Yeah, any number. This is math. So it's the principle that we need to work with. Any number. Any number.
Okay, thank you, sir.
You'll see we'll go down. But if we are talking about digits, then we talk about 10 digits because there's no other digits, right? And they'll tell you 10 digits without a 0. That means it makes it 9. 10 digits without even numbers. So you've got to keep those restrictions at the back of your mind. So we can count the number of stars. That's when God ends the whole world. He wants to start counting stars. Okay. All right. 10.1. There are 10 people. There are 10 lanes. People cannot be repeated. So in how many ways can 10 people be arranged? 10 factorial. Number 1. But don't leave your answer like that. You get 1 mark. It's a mark you mustn't be losing. It's 388 Am I right?
362.
Oh. 3.
8800.
Okay. 1 mark there, 1 mark there. We're done. You do number 2 for me. Four athletes taking part in the event insist on being placed in lanes next to each other.
120,000.
It means you group those ones as one. How many of them? 4.
Yeah.
Okay. Don't let's even make it very difficult. So there are 4, right? So I'll start with those 4. All right, I'm done with the 4. But now there are 10 in total. 10 minus 4, 6 plus 1, 7. Are we okay, everybody? Did that make sense? Just group them. So if I group them, then there are 7 people in total because I have 6 other ones plus the group. Make sense? If I group the 4, I have 6 people plus my group, which makes it what? 7. That's where I get the 7 from. Then I go into that 4 and rearrange them again. Okay, check the last one. The last one says probability though. But I want us to see if we can try. If lanes are randomly allocated to athletes, determine the probability that Ben will be placed in lane 1, Ntlantla in lane 3, Owen in lane 5. Let me help you with this. Watch the dynamics here. So, that's why I said it's better to work with manual stuff. Look at it. So we have lane 1, lane 2, lane 3, lane 4, 5, 6, 7, 8, 9, 10. As you keep doing this, you start doing it in your mind. Okay. This is lane what? 1. Who's there in lane 1? Ben. Lane 3, Ntlantla. Lane 5, Owen. And lane 7, Derek. Are you aware that we have already fixed Ben in lane 1?
Yes.
How many options do we have there? 1. It's only Ben. Because he has been fixed. His name is written there. How many people can sit in lane 3? Lane 3. 1. It's only in Atlanta there. How many people can be in lane 5? Only 1. It's Owen. Derek? Okay, watch this. So I already have, before the others come out, these guys are standing there warming up. They are the ones that know the Minister of Sports. So they are already there. They chose those lanes. I have 6 people who are coming out. Mr. Price Sports, Foshini Sports, and all of that. They are trying to get in. They are trying to get into those lanes. In lane 2, how many people can be there? 6 options. Mr. Price. Total Sports and the others. It's now 5. Remember there were 6. Make sense? So my first option, it could have been any of the 6. Now 1 is fixed. They are remaining what? 5. 1 is fixed. They are now remaining what? 4. The other one? 3. Does that make sense? What's the answer? Then I'll deal with the probability. But first, let's count. 720. Now, this is just the number of ways. But look at the examiner. The examiner is saying what? Probability. So what is the probability? 720 over the total outcome. What's the total outcome? 10 factorial. And remember, your answer must be less than what? Because the probability. What's your answer? Just give me fractions. No, fraction. 1 over 50, 40. Done. Guys, did the counting make sense? I'm not really worried about the probability. Probability is grade 11. But if the counting makes sense, why we have 1, 1, 1, 1, 1 there? Because those places, we only have one option for them. Are we good? Lovely. I'm happy if we are good.
So,
Yes.
will it be alive if we calculate the probability as 6 factorial over 10 factorial?
No. But you must know why you're saying 6 factorial though. Okay. Can I add one more event as we go into the questions? If I don't want the books to be together. So I have a class, I'm having a class, and I only have 5 learners. But Jack and Grace are dating. They're not going to be focused in my class. So what's the arrangement? I have to separate Jack and Grace. So I want them to sit in such a way that Jack and Grace don't sit together. Are you following? Items not together. So this is number 6, right? I think. Number 6. Items not together. And it's, guys, not together. Not together. Ooh, English. This is very difficult to do. Very difficult, but if we go back to, I want you to listen to this, go back to the complementary events we spoke about. It's either they are together, watch this, it's either they are together or not together in terms of probability, right? Okay, so if I were to say probability of an event happening plus the probability of the event not happening, we say that should be equal to what? 1. I want to create something here. What is probability of an event happening? Number of events over the total what? Sample space plus number of the event not happening over what? The total sample space we are saying is equal to what? 1. Denominators are common, right? Let's bring that together. What do we have? The number of events happening plus the number of events not happening. This should be outside. Not happening. over the total sample space, cross multiply number of events happening plus the number of events not happening should be equal to the total what? I want them not to happen. Is the total minus them happening. That's where we are going. I just didn't want to give you that formula. I wanted to see the way it comes from. So, not items not together. Items not together would simply be together. No. Total minus together. Total minus together. Then it's now, if you wanted to try it by separating them, you would suffer. You are going to suffer. Just A, B, C, D alone, you would suffer. Such that A and B don't stay together. It's hectic. So it's easier this way because it's either they are together or they are not together. So we find together and subtract from what? Sum. Okay, example. 7 people are to stand in a row. In how many ways can they stand? If 4 particular people must not stand together. Now the examiner has given me a word, must not. If the probability that it would rain is 0,2, what's the probability that it will not rain? 0,8, 1 minus. So in this case, what do? We need to find together. There are 4 people, right? So what's my answer? Check this. I'm going to do it in one step. Since there are 7, total is what? 7 factorial. Nomti, I hope you understand the factorial now. 7, 6, 5, 4, 3, 2, 1, right? Now, minus. Talk to me. If they are together, what are we going to say? There are 4 people, right? So let's deal with those 4. Now, if we remove those 4, how many people do we have left? 3. But the one that is removed is one group, which makes another what? 4. Does that make sense? Why are you lost? Okay, check. A, B, C. It's the same thing we've been doing. F, G. 1, 2, 3, 4, 5, 6, 7. One group. So how many people are they together? 1, 2, 3, 4. 4 factorial. Then going inside that group, another 4 factorial. Put that in a calculator, get an answer, and unsclach. 4,400. Where's Ferdows? I saw her earlier on. Is she still here? Ferdows Kane. I saw Laika earlier on. Is she still here? Yay, Laika. How are you? Okay. Google, hello. Guys, did it make sense? Are we okay? Together minus, total minus together. That will give us not together. Let's try a few more questions. Let's look at some structured questions. As if I knew. Look at 11.2.3. As if I knew I was already there. Okay. 7 learners, Bonolo, Jeffrey, Temba, Richard, Tandeka, Godfrey, Palisa, are standing in a line. So we have a line, 7 of them. In how many ways can the learners be arranged in a line? Please start answering. Answer the whole thing. I would mark with you. Let's give you 5 minutes. 5 minutes is too much. I see the department. They put the easy things at the end. And imagine, in my revision of how to get a level 4, I'm saying give me 5 marks here. Because this is considered as under probability. I want only 5. Ridiculous. Oh, Mohammed has sent me a nice question. We'll look at it now, Mohammed. Guys, we should be done. Although I said 5 minutes, like no. It's like I'm actually going to get a cup of coffee by giving you that 5 minutes and come back. Numti? Numtai? Numtai? Are you there?
Yes, I'm here.
Okay, do you want to help me?
With this question?
Child, with what? Child?
Yes,
Come, let's go. Number 1?
Number 1, it's 7 factorial.
7 factorial, which is 50/40, I think. So guys, please look at the way I'm writing my answer. That's what we want you to write. Okay. Number 2, learners can be arranged. Bonello, Jeffrey, and Temba must be next to one another in any order. Okay. So what do we have?
So I will use the formula.
You use the. I need
So
it.
7 minus 3 plus 1.
Which gives us what? 4 factorial times what? 3 factorial. What would that give us? Is it 5? They add 3, right? Yeah, it's 5 factorial, Michelle. 5.
7 and 3 plus 1. Oh yes, 5 factorial, yes.
Yeah. So what would this give us?
720.
It will give us 720.
Beautiful. And number 3, what is the probability? So please take note. They are looking for probability that Tandeka and Palesa will not be standing. Look, I can do it in 2 ways. I can look for the probability that they will be standing and subtract from 1. Or I can just go by saying probability. Okay, Michelle, are you with me? Tandeka
Yes.
not standing. What do you have?
So we have the total, which is 7 factorial.
7 factorial minus
2 factorial, 6 factorial.
But remember, you're not done. That is number over 7 factorial, total sample space.
Oh, you did it in one step, okay.
Yeah, I can do it in one step. You're not going to be penalized. All right. What's your answer?
Just give me a second.
Yes, there's a hand there. Naledi. Hello, Naledi.
Sir, can you please explain to me how you got the 6 factorial?
Okay, Naledi. How many people do we have? 7, right?
Yes, sir.
Let's group 2 people. I told you every time they are saying they should stand together, they become one person. So count, how many do we have now? 1, 2, 3, 4, 5, 6.
Oh.
Which we said you can actually do by saying n minus r plus
1.
Remember, use a sigma notation system. Top minus bottom plus 1. If you want to use that. Okay. What's our answer?
5/7.
Done. Guys, we are done with counting principle. But you are not done. Let's keep looking at questions. You know how it goes. But the whole idea makes sense, right? Yes, talk to me. There's a hand. Mufaro. I have Mufaro, then I have Ntebo. Mufaro, quickly go ahead, talk to me. Thank you, Divine 5/7. Mufaro? Yes, talk to me.
I said 1 minus probabilities they are standing next to each other.
Absolutely.
And they got 2 over 5.
Let's do it together. Let's do it together. I also mentioned that method. Come, let's say, what is the probability of them standing together? Now, if they are if 2 of them are standing together, it will be what? Okay, let's do it step by step. Standing together. Let's count the number first. 2 of them are standing together, right? It's 2 factorial. Do we agree?
Yes.
Now, there are 7 people. We subtract 2. We're left with what? 5. Plus the group, 6. We're good. All right. Now, what is the probability going to be of them standing together? 2 factorial, 6 factorial, over 7 factorial. Do we agree?
Yes.
Now, probability not standing together. What will it be? 1
minus the probability
Yes.
of them to be next. Yeah.
You must get the same answer. What are you getting? Let's check.
5/7.
5/7. Because, guys, do you notice that we are just going around in circles? What is 7 factorial over 7 factorial? 1 minus.
Yeah.
So maybe you made a mistake while typing. Is that okay? Are we okay now, Mufaro?
It's good.
Okay. Ntebo, Nkoko. You want to talk to me quickly?
I was going to ask the same question.
Oh, beautiful. Lovely. Okay. Oh, we're getting to some interesting stuff now. Given the digits 3, 4, 5, 6, 7, 8, and 9, calculate how many unique 5-digit codes can be formed using the digits above. So we restricted here, right? If the digits may be repeated. Work it out. Now we get into the yummy stuff. Let's do it step by step. Number 1. We want a 5-digit what? Code.
So will it be 7 to the power 5?
7?
To the power 5.
I'm not sure. Let's do it this way. Michelle. Maybe you are correct. How many digits do we have in total? 7. So how many can go in the first place? 7. They can be repeated. 7, 7, 7. So 7 to the power 5 is correct. And what's your answer? 16?
807.
So repeated. If you go back to what I told you, n to the power r. And your calculator has it though. It has it. I know you don't see it. It has all those permutations and combinations on the times, on the division, but I know you don't know how to use them. Okay, 11.1.2. Digits may not be repeated. Guys, just do it manually. Do it manually. What do you have? 2520. Can somebody confirm that for me? That the guys here are wrong? What did you do? It's right. Okay. Shamil, what did you do? 7 times 6 times 5 times 4. You said what? 2? It's kind of easy manually. That's why I'm trying to hold the formula usage a bit, because some of us will forget. Did that make sense? And you see here, it's not factorial because I don't have 7 spaces. Okay. How many unique codes can be formed using the above if... all right. Let me help you. Let me take you through. Digits may be repeated, but how many codes are we forming? 3. So please, everybody, I need you. Well, I'm going to slow it down now. I have 3 digits, 3-digit code. If digits may be repeated, lovely. Don't start until you are done with reading everything. Okay. The code is greater than 400, but less than 600. I already cannot start with 7. What do I mean? These are the possible numbers, right? 3, 4, 5, 6. Let's, because I want you to see. What do we have? 3, 4, 5, 6, 7. I want 3 code, which is 3, 4. Okay, ideally, this is what I should have, right? But it must be greater than 400. I cannot start with a 3. Make sense? Guys, did that make sense? Let me get that. Let's get that option. We cannot start with a 3 because I want the number to be greater than what? 400. Okay? And they said what? Less than 600. You got to read the whole thing through. Can I start with a 9? 8? Can I start with a 7? No. Less than 600. Can I start with a 6? No. Because the number must be less than 600. I can only start with a 4 and a 5.
Oh, I see the description. Okay.
Let me know if we are on the same page with my counseling. Divine, your thumbs down. Please talk to me. Why is your thumbs down?
So I want to ask, okay, please explain as to why we cannot use 3.
Give me a number that starts with a 3, a 3-digit number that starts with a 3 that is greater than 400.
Oh. Okay, I understand. Thank you.
Okay. So the number that, whatever number we form must be greater than what? 400, but less than what? 600. I saw a few other thumbs that were down. Can I still see? Is there any thumbs down with make cancelling? So 3 is out. And they said it cannot be bigger than what? 600. So I can't actually start with 6 as well. Mind you, there's no 0 in this number.
Yeah, so it automatically is.
So I can start with, so my only options is the number must start with 4 or 5, which leaves me with what? 2 options. Let's go check. The code is divisible by 5.
5 must be in the last.
So it means that if it must be divisible by 5, the only option I have here is 5, right? How many options? 1. Now, how many numbers can be in the middle? Digits may be repeated. 1, 2, 3, 4, 5, 6, 7. Answer is 2 times 7 times 1, which is 14. Talk to me. Let's discuss. Let's discuss. Let's discuss. It's just something you don't run. Remember, you're not Molefes. I always say that. You don't run. Who's giving me this answer? You're wrong. Brian, you're wrong. Because there's so many things that you did there. Yes, you guys are not Molefe. I see somebody crying now. Who's that? I missed that name. It starts with an L. Please come, talk to me. Let's give you tissues. We need to deal with it quickly before we move on. Vukudo, your hand is raised.
Hi, sir.
Hi, Nana. How are you?
I'm good, sir.
I'm very well. Talk to Moa.
Sir, I do not understand.
Where are you lost? Tell me exactly where I lost you. I'll find you.
From when you started by putting the 2.
Do you know why I put the 2?
No, sir.
Because I only have 2 options. That space can only be filled with a 3 or a 4.
Okay, sir.
Do you know why it's only a 3 or a 4? The number must be, come back, let's come. It's a 3-digit code. It must be greater than 400. I cannot start the number with a 3 because I want the number to be greater than 400.
Yes, sir.
And it's only a 4 or 5. Can the number start with 6 when I want it to be less than 600?
No.
Good. So I cannot, that's why I cancelled my 6, 7, 8, 9, and I also cancelled a 3 because a 3 would make it less than 4. A 6, 7, 8, 9 would make it bigger than 6.
Yes, sir.
Good. Are you okay with the 2?
Yes, sir.
Okay, which other one? Where did I lose you?
Yeah, I'm fine. Thank you, sir.
Divisible by 5, you find there?
Yes, sir.
That number can only end with a 5. And then in the middle, we don't have any restriction. It can be repeated. You know the one that I was thinking, they will tell you digits can still not be repeated. Yeah, that's now. Yes, talk to me. We'll come back to that. Let me see whose hand is up there. Tego Fatu?
Good day, sir.
Hi, good evening, Nana. Talk to Moa.
Sir, can I ask, why does the number end at 5?
Because they said the number must be divisible, the code must be divisible by 5. For a number to be divisible by 5, it must either end with a 0 or a 5.
Good question.
Okay, thank you, sir.
Okay, beautiful. Yes?
This one is simple because they say divisible by 5. And we know a property of 5 is the last digit is either 0 or 5, since there is no 0.
The 5, yeah.
But if they say divisible by 3, then how would we do that?
Divisible by 3, you've got to first know the properties of numbers that are divisible by 3.
Yeah.
Okay, that one is hectic.
Yeah.
All right? Because you have to add all the numbers together. If that number is divisible by 3, they won't give you something like that. They would either give you something even or odd. They are boring. No, bruh. There are questions where we fight here, even as educators, we fight. There was a question last year that was wrong. We disagreed completely with the memo. and people went on YouTube to do the memo. Like, if you don't know the answer, just skip. When you are busy doing the video, just say something happened, that part is corrupted. Cut the video. Don't sell your ignorance for free on YouTube. So there are questions that are. So those ones will take us. Look, we have some exciting questions. I can look for them. I'll look for them. All right. Yes, I'll look for them. Okay, I'll look for some for you. Is there anybody who's still lost? Let's see. Okay, if I tell you that digits may, okay, let's see. Nazifa, hello, stranger. Nazifa, talk to me.
Hi, sir.
Hi, stranger. How are you?
I'm good, and you?
I'm okay, stranger danger.
So I wanted to ask you, where did you get that one from?
Because remember, these are number of options. Okay? So the one tells me I can only put a 5. The only number that I can put here is a 5 because they said the digits must be divisible by 5. So for numbers to be divisible by 5, it must only end with a 0 or a 5. But we don't have a 0 available for us to pick from.
Okay, thank you, sir.
All right. If the examiner told us that digits may not be repeated, let's work it out. I think I'm getting fired up for that. We have the same story, but digits may not be repeated.
But we know 5 and 4 is the denominator.
Digits may. It's quite simple though.
Yeah.
But hold on, you think so? Hold on. Let's start. I want to take everybody through that. So sometimes this thing is not just at face value, you be careful. Still greater than 400 and less than what? 600. We still have this there. Still divisible by? Now, it means I am putting a 5 here. Automatically, this is out. Please understand, because the number must end with 5. Whatever code I use, it means I cannot start with 5, since 5 cannot be repeated. So my only option here is 1. It's 4, which is just 1. Remember, we're counting. In the middle, 5. Because how many options do I have? It could be a 3, it could be a 4, it could be a 6. No, it can't be a 4 because I've already used 4, right? It can be a 4, it can be a 5, 6, 7, 8, 9. I have how many options? 5. And I have here 1. Please come, let's discuss again. Let's talk about the digits. Make sense? Because I cannot repeat. Teho, is this an old hand or a new hand? Oh yeah, yes, Lucayiso, yes, that's the name. Sir, where did the 7 come from? Thank you, Sisanda. It's the total amount of numbers there. Thank you, Sisanda, for helping me there. Lucayiso, are you fine now? They gave us the digits, 3, 4, 5, 6, 7. Okay, beautiful. Teho, can I put down this hand? Or you have a question? I don't know if, okay, Teho, if you have a question, you raise up your hand again. I don't know if, Afifa, how are you? Okay, let's try a few more questions. This is getting interesting. Oh, here's another one. Can I just keep quiet for this one? Do the whole thing through. I'll give you 5 minutes. Just wanna. Oh, Mohammed will do your question now. Sorry, I keep forgetting. I'm here, Charles. Talk to me. I didn't run away. I'm here.
Yes, okay, I have a question. You see when it gives us the example on how they can be formed, right?
Yes.
Can you talk about that one number or that two separate digital codes?
What do you mean?
Like,
They said a 3-digit code, right?
okay,
So example is 567.
oh, that's one thing.
Yeah, that's a code, 3 digits.
Okay, and then the next code.
The next another code 218, etc.
Oh, all right, got it.
Okay.
Thanks.
It requires some thinking.
So the previous question was asked, would you have not allowed? It's not allowed. Yeah.
Hi guys, I'm here and you only have 6 seconds left.
Okay.
Okay. Who wants to take me through? Who's bold enough? Nabira, you want to take me through? 21. Is it 21? Ahmad is 21, right? Or 22? Nathan. I'm not sure. 21 or 2. Who wants to take me through? Anybody? Feel free. Nabila, come talk to me.
Yes, sir.
Okay, Mohammed.
So for the first one,
Yes.
it's going to be 9 and 9 and 9.
You sure? It's my pen. 1 second, Mohammed. I'm coming. Oh, okay. So we have what? A 3-digit code. Okay. Repetition is allowed. Is it 9? Do you have 9 digits available? Yes. So it's 9 times 9 times 9. What is that? 729. Thank you very much. We're done. Number 2, such that the code is greater than 500. You talk to me.
85.
Okay, let's see. Guys, we're going to open the floor. I want to open the floor for if you agree, if you don't agree. You said it's what? 5?
And 9. Times 1.
I would like to disagree or disagree.
Okay. Hold on. I'll write all the possible options. Let's stay on 9.2 for, number 2 for now. I'm having people here who are disagreeing with you. Yes. Okay, before you guys here, let's see. Anybody from home, you want to agree with him or disagree?
Sir?
Yes.
Sir?
You disagree?
I wrote, yes, sir.
Okay, what do you think?
Sir, I wrote 5 times 4 times 3.
60, right? No.
Yes.
100. Okay, I want to see all the possible options.
So, sir?
So 1 second. Is it 60? Oh yeah,
Yes,
60.
sir.
60. Okay. Yes.
I disagree.
You disagree. Divine. Okay, shoot. This is what I want.
I think, I'm not sure, but I do think it's 1 times 4 times 3.
Okay, I also disagree.
Which will give you 12.
We have a 12. Okay, and I want as many answers as possible. I want to see your thought pattern. Come.
What's the final answer?
So,
Yes. Who's speaking? Now, lady. Shoot.
so I said 4 times 3 times 2, which is 24.
24. Okay. Any more answer? And guys, I'm going to ask us to tell, I want to listen to why you are saying those, why you're picking those numbers, because it's important. Awande has 5 times 8 times 9. 280. Is it 280 there? Okay. Anybody else with a different answer? Please feel free. We're all learning together and just enjoying this class.
I agree with 5 times.
So it's 360.
So it's
360. Oh. Okay. Different answer? Okay, hold on. Let me do it online first. Online, yes?
So I got 5 times 8 times 7, which is equal to 280.
5 times 8, that's Nazifa there. 280.
I got number 2's answer.
Okay.
Sir,
Yes, Michelle?
I got 4 times 5 times 0.
Times 0.
Times 0.
That means we can have a code.
So,
Okay.
I mean, now one number is
Yes, who's talking to me?
so I got 4 times 9 times 8, which is 280.
Zoe. 4 times 9 times 8, which is what? 288.
280.
Okay.
So I got 4 times 5 times 4, which is 80.
Fatima, 4 times 5 times 4?
Which is 80.
80. Okay. All right. Yes, Mufaro?
5 times 9
5 times 9
times 9
times what?
9
Times 9. All that give us 81, 5, 4, 55. 405. Okay. Is there any different answer? Because guys, this just shows how we think, how we are looking at the questions, right? Okay. 5 times 4 times 0. How come you're having a 0? You and Michelle. It means we can't have a code. Yeah, I think if you play the Super Bowl, there must be an answer. You must win. Okay, wait. Such that the code is greater than what? 500. Okay. We have 1 to 9. Let's go on a fresh page and see. 3-digit code, right? Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. We want the code to be greater than what? 500. And what? What's the repetition is not allowed. Interesting. Okay. Definitely, we all agree that out, 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 out. Wait, what our sample space? From what? From, yes?
May I please change my answer?
Okay, 1 second. Who am I talking to? Is that Naledi?
No, it's Divine.
Divine. Which one is your answer? Which one is your answer?
My answer was 1 times 4 times 3.
Okay, what should I make it?
1 times 8 times 7.
1 times?
7. 8 times 7.
And that will be 56, right?
Yes.
Okay.
Thank you.
All right. Okay, guys. Let's do it step by step. We agree that 1 to 4 is out. Can I start with a 5? Yes. Because there's no 0 here. So 5 would work, 6 would work, 7 would work, 8 would work, 9 would work. But repetition is not allowed. Interesting. Okay. All right. Please listen. So, if I start with, let's make it manual because I want us to see. If I start with a 5, please, I said if, I'm not saying that. If I start, I'm deciding to start with what? A 5. I'll have 1 here. If I start with a 5. It means here, I cannot have a 5 anymore. Right? I'll then be left with 8, right? Okay. I just wanted to follow through closely. Let's say I now use a 1. I have 7 left. Does that make sense, everybody? Does that make sense? I want us to take it step by step. I used a 5. Which means I could use a 6. Which means I could use a 7. Which means I could use 8. Which means, so if I use a 5, my answer will be 1 times 8 times 7. But I have 5 other options that I can use. I could, because it is either, wait, hold on, it's either I start with a 5 or I start with what? A 6. If I use or, if I start with a 6, it's a 1 times what? 8 times 7. Does that make sense? Or I start with what? A 7. Or I start with 8. Or I start with, so it gives me 5. So my answer should be 5, let me see. 5 times 8 times 7, 280. I don't know if we all agree. Please, let's discuss. I saw a big thumb there going down. Yes, Sisanda? Okay, now,
I don't understand.
now, lady, okay, fine. Now, lady, you could have gotten it right because all you did here was you only considered the number 5. So let's go back again. That's why I wanted to break it down for you. To say, okay, Sisanda said, Sisanda, do you want to keep your mic on for me?
Yes, sir.
All right, beautiful. Sisanda, let's work together. Remember the numbers we're writing up there are options. Okay. So Sisanda, are we okay that we cannot use 1 to 4?
Yes, sir.
Okay. And I'm saying for simplicity, let's decide we want to use a 5 because these are the options I have, right?
Yes, sir.
So how many options here using a 5? 1.
Yes,
Now, digits may not be repeated. Since I've used a 5, I am coming here to cancel a 5.
yes, sir.
So how many numbers do I have left?
4.
Why 4? Don't confuse yourself with the number and the count. That's where people get confused. Sisanda, I have 9 options.
Yes, sir.
I have removed a 5.
Oh, we have 8 numbers there.
That is you see, the numbers I get you, the numbers are always confusing sometimes. 8 options.
Yes, sir.
Now, because I've used a 5, it is also out here. All right? And somebody
Yes, sir.
said, let's use a 1. How many options do I have?
7.
Beautiful. So it is the number of options. Don't worry, I know that when we start, the digits and the options are always confusing. So these are options if I use a 5, which will be the exact same options if I use a 6. Exact same options if I use a 7. Exact same options if I use 8. Exact same options if I use what? I can use any number.
Thank you, sir.
Okay, just 1 second. I can use 8 here. It still gives me 7. Any number. Remember, it's only one of the options. That's what we were saying. We have 7 options that we can use. Okay, there's a hand. Talk to me. I've got Naledi Tehufatu. Naledi?
So I get confused when you say the answer is the one that says 5 times 8 times 7. I'm getting confused by the 5 that's there. I understand this one, but when you choose the other answer,
Okay.
it says 5 times 8 times 9. I'm
Okay.
not confused there.
Okay, Naledi, keep your mic on for me. So what are we starting with here? Starting with a 5, right?
Yes, sir.
Okay, come. Let's start with a 6. Don't worry. I'm very patient. I'll take you through. Start with 6. Okay, can we make it smaller? 3 digits number. Remember, I can no longer start with 1 to 4, right? Okay. So, 6, 7, because I've already started with a 5. Can I start here with a 6? Now, lady,
Sir?
if I start with a 6, it will still be greater than 500, right?
Yes, sir.
That's another option. So I have one option, starting with a 6. Are you with me?
Yes, sir.
Okay. Numbers cannot be repeated. So remember, it's another set of code. I have started with a 6. I will cancel a 6 here. How many options do I have? Good. Now that I have used a 6, remember I have used what? My 6. And what are we saying? Okay, I started with a 6, right? So I can no longer use a 6 here. I have 8 letters, 8 numbers left. Now 6 is out, but I've also used any of these numbers. Let's say I used a 5. I have 7 options left. Does that make sense?
Yes, sir.
Now,
Yes, sir.
if I go ahead and start with a 7, are you aware that I'm still going to have the same thing?
Yes, sir.
If I go ahead, which is another sample space, I can start with 8. I will still have a count like that.
Absolutely. Yes, sir.
And I could still have what? If I start with a 9, I'll have the exact same number of options. So this plus that plus that plus that plus that. How many are you adding together? There are 5 of them.
Oh, okay.
So the answer that is 1 times 8 times 7. Now times 5, because we are repeating them 5 times. That's why I chose that one, because 5 times 1 is 5. Maybe the person who gave me it was lucky. They didn't mean that 5, but that's where the 5 came from.
Okay, thank you, sir.
All right, Tego Faso, talk to me.
Also, I wanted to ask the same question that you just asked.
Oh, okay, beautiful.
Okay.
So we're good.
Thank you, sir.
We're good. All right. Lovely. Such that the middle digit is 5 and the repetition is allowed. What do you have for this one? Nancy, are you okay now?
Yes.
Okay.
I see where the 0 from here.
Where did you get your 0 from? I want to understand the 0.
Because you see, the first one I get 4 numbers. 4 plus 5 is 9. And I have 9 numbers, so it's 0. 9 minus 9 is 0.
Okay, but you're fine now. Are you okay now?
Yes, 100%.
Okay, is it Godfrey that also gave me the one with the 0 there? Are we also okay now? Huh? Oh, you gave me that 0. Okay, are you fine now? Lovely. Such that the middle digit is 5 and repetition is allowed. Okay. I'm interested in your answers, so I'm going to create a fresh page for this one as well. Yes. Please, you want to share answers with me here?
1 times 9 times 9.
Okay, sorry, 1 times 9 times 9. Yes, Mohammed, what's your answer?
27.
Huh? I disagree. Wait, is this the order? Is this the order?
No, my order is big size. 9 times 1 times.
Okay, please give me that because it's messing up with my head now. Okay, is this what we have?
Yes.
Okay, let's see. The middle and, okay, this is perfect. This is perfect because we can have 9. The middle, we can only have one number now, which is a 5. And that number can be repeated again. It's getting there. We're getting there. Don't worry. I'm not in a hurry to... We're getting there. Okay. Let's look at this one together. The letters in the word Johann are arranged in any order without repetition. What is the probability that the word Johann will start with a J and end with the letter A? You give me an answer. You have 3 minutes. Think through. We're doing number 1. Don't worry about these circles that you see. Johann. 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 Yeah, Calvin. I said Johann. Johann. Iman, how are you, my child? If anyone is done with the Johann question, you may please share your answers, your wrong answers.
Yeah, sir.
Oh, you want to share your wrong answer quickly, Mohammed? Come, let's go.
Yeah, I got
I'm just pulling your legs. 1 times 4
times 3 times 2 times 1.
Okay, remember it's probability. Guys, always look at the words. They didn't say count. They didn't say in how many ways. They said probability. I see that Michelle also just gave me 6 factorial. Michelle, where are you getting 6 factorial from, though? Okay, Mohammed, take me through. You said Johan. Right?
I think the probability.
Okay, give me the count. Give me, how did you count? Let's see your count first. Hey, they said you are right. Let's see.
Not fully.
Not fully.
I don't know number 5.
Okay. If you must start with J. Yeah, go ahead, Mohammed.
So it starts with J.
Yeah.
I only have 4 letters.
Sorry? Yeah, go ahead quickly.
Now you have 4 letters left.
Yep.
Now if you use 1 more letter, you have 3 left. Then you have 2 left and 1 left.
Okay, what should I write in the top? What should I write on the top? Guide me through.
2, 1. Then you have to go HN, so there's 4 there.
I disagree. It must end. If you say it has, if you have 4, it means check. I disagree.
It's 3.
So A must end. So let's fix those ones first. You see, fix those ones.
Sir,
Yes.
I meant 6 times, sir.
6 times. But 6 is wrong. Where are you getting the 6 from? Joanne is even 5. Why 6? Guys, don't just jump to use factorial. I see I one day you also jumping to use factorial. No. Deal with the restrictions first. Let's deal with it. Yes, Michelle?
Can I continue?
Yes.
Okay, so you put 3 in the second position,
Yeah.
and then I got 2,
Uh-huh.
and then it's 1.
Guys, this
Then
is
6.
yeah, then so it is
Then it's that 1.
so probability will be what? The probability, since they said probability, it will be what? 1 times 3 times 2 times 1 times 1 over 5 what? Factorial. What's your answer? Please let's go through that count again. Did it make sense? Did it make sense? That count. So let's always start with the restrictions. Okay? The J and the A are constant there. So already 2 letters are gone. Yes, talk to me. Linda? Why is it 5 factorial? Total sample space. There are 5 letters, remember? Total sample space. When we say probability is the total. There are 5 letters. So the number of ways that 5 letters can be arranged is 5 factorial. Let's see. Any more question on this? Let's see. Let's take all the questions. No more. Everybody's okay. Beautiful. The last one for the day. Oh, check. Look what I have. I have this. I have that. Ooh, I have that code. Because this thing was just getting more interesting as I was. Then grade 11 probability. Yeah, you know. Just like the way we did with stats. But awesome. Let's answer this last one. So I would then say, guys, after this, you can look at any question paper. You'd find it is the last question. Start playing around with it. And Mohammed sent me a question. Let's see if we can quickly answer this one, then answer Mohammed's one. The Lawrence family takes family photos. The photographer arranges 3 married couples, 7 children, and 2 grandparents. Okay, let's see. Does this make sense? Oh, they told us M is what? The married couples. Grandparents. How many grandparents? 2. And C is children. 1, 2, 3, 4, 5, 6, 7. How many different ways can the Lawrence family be arranged for the photo? Oh, wait, I didn't read. The couples stand husband and wife together at the back. The couples stand. So I cannot go and stand with somebody else's wife. Got to stand with my wife. Okay. So let's look at it together. How many couples do we have? Please, I want to take this line by line. How many couples? 3. So the 3 couples can be arranged 3 factorial. I hope that makes sense. Let's go with every number. Please stop me immediately if you are lost. Does that make sense? Couple 1, couple 2, couple 3. Please thumbs up, thumbs down, because it's going to be quite a lot. So, where can we find this video to revise again? Calvin? Okay, we'll talk in the next 3 minutes. Okay, 3 factorial. We good? However, they said the husband and wife can stand together. It could be husband, wife, wife, husband. Does that make sense? So that makes it times what? Does that make sense, everybody? Okay, talk to me. Yes? Michelle, quickly.
Oh, sir, you already explained it, sir.
Oh, with the 2 factorial, right?
I wanted to ask. Yes, sir.
Oh, beautiful. Okay, so I think we're done with the wife, the couples. Grandparents? Because we could have grandpa, grandma, grandma, grandpa. How many kids?
7.
And the kids could be thrown anywhere, just hanging on the corridors. All right. Talk to me, we are done. In how many ways? It's not probability, we're just counting. Case closed. Are we okay, guys? Are we okay with all the numbers? Any question? I want to deal with Mohammed's question now.
So,
Yes, talk to me.
for the kids,
Yes.
there are other ways they can be arranged. Like how you say, you see the married couple can be husband, wife, or wife, husband.
Already that 7 factorial takes care of everything.
So how come that 3 factorial didn't take care of everything?
The 3 factorial is for the couples, remember?
Yes.
So we have couple, okay, let's make it easy. Couple A, couple B, couple C. Are you okay with the 3 factorial?
Mm-hmm. Yes.
But there is A1, A2, B1, B2, C1, C2. Each of them, wait, I think we are even missing something. Okay, let's go back. 3 factorial for A, B, C, right? Are we okay?
Yeah.
But if we look into each of them, we missed something actually. I think we missed something. This is 2, this is 2, and this is 2. We missed that.
Oh no.
A1, A2, A2, A1. That's 2 ways.
No, but you're not saying with somebody else's wife.
Yes, but check. Let me make it easy. I could have A1, A2, B1, B2, C1, C2. A2, A1, B1, B2, C1, C2. Make sense? I only change the A now. I could go ahead and change the B and still leave the 2. I could go ahead and change the C and still leave the 2. So this is what we're saying. A, B, C, 3 factorial. We missed something here. Let's fix it. Let's go again, everybody. Are we okay with 3 factorial? Now, for A alone, times 2. 2 factorial is something as 2. For B alone, times 2. For C alone, times 2. Let's quickly clear this. Is this okay with everybody? Why I'm saying 2, 2, 2? Because each of them, you have to go back into, the way we're going back.
Yeah, we were saying only taking them as one whole.
Yes, first we take everybody as one whole, which is our 3 factorial, but we go back into every group and factorize them there, or factorize them, or whatever word. Are we okay with that? Grandparents are 2. Remember 2 factorial something as 2. Now, Nomti, there are 7 kids. So look at this place, this particular position. How many kids can I have there? 7. No, it could be 7 of them, right? Mm-hmm. If 1 is already there, how many kids will be here?
6.
and then 5, 4, 3, 2, 1.
That's okay. That's why we say 7 factorial. All right. Please, very tricky. So first 3 factorial is grouped A, B, C. Then you go into every group and 2, 2, 2. What's your answer? 4. Let's take questions quickly. Are we okay? Let's see if there's any question here. How do we know when to use the factorial? I did explain as well. If you have to arrange n things in n places, I have 5 books and I have 5 sports, 5 factorial. I have 10 things and I need to arrange them in 10 places without repetition. These are kids. Even if they are twins, they can't be repeated. Are we okay there, Tegufaso? So you've got to check.
Yes, sir.
Okay, so you've got to check how many items do I have? I have 6 items. How many spaces do I have? I have 6 spaces. And I cannot repeat any of them factorial because it's 6, 5, 4, 3, 2, 1. Okay. Let me see. Mohammed, let's quickly. I'm just going to read this one for us. My own we can suspend. My own questions. Okay, please look at this. You have to choose a password for your new Facebook profile. Just tell them I don't have Facebook. 3 marks. Okay. Just tell them you don't have Facebook. The password must be, you guys are laughing, in this format. Okay, they have very funny symbols here. Okay, we'll just try to write the symbols out. Just tell them, good, I don't have.
That's why they said you. They know you don't have Facebook.
Yeah, that's why. Okay, so they said where this symbol is a digit. Let's see quickly. Zeros are not allowed. So zeros not what? Allowed. Okay, quickly let's sort that out. What do we have? 1, 2, 9. And the at is any vowel. English. 5. A, E, I, O, U. Okay. You may repeat any. These guys are silly. Repeat digits. You may repeat digits, or simple, and you may not repeat a vowel. Not repeat vowel. How many passwords can be formed? Do you want to try quickly? 2 minutes. Having gone through a few questions, I'm sure. Wow. You're done already? Okay, let's see if we can have an answer from home. Divine 14,580. Wow, you guys are, Michelle, 14,580. You guys are now hackers. You guys can now hack a password. You guys can now hack. So you just need to ask what are the criteria for the passwords. Is it a birthday in the family? Then you can just get it. I'm just sorry for your parents that are working at the bank. Zulu, what do you have? 14,580. Okay, please, can somebody take me through? What do you guys have?
9 times 9 times 9 times 5 times 4.
Digits can be repeated, right? Repeat digits. So we have 9 times 9 times 9. And so 5 times 4. You said what?
14,580.
All right, beautiful. Thank you very much, everybody. I hope the beginning was quite nice. It's a very interesting topic. So the idea is to now adapt each case with what we know. The cases will be different, I promise you. The cases will be different, but the principle is to be calm, because you might be blind to some restrictions. You think, I got it all right, but there's one number that is just, and we need to take care of that. Next week, or when we meet again, I'll be looking at one that says at least there should be something. You see, those ones are very also tricky to say there must be something, but at least we should have this, at least or at most. So it's all about counting and applying the knowledge to each question differs. Okay, you definitely find some that are, similar. I wish we had time. This one is a lovely one. The way I'm looking at it, it's a lovely one. 6 marks. Can we finish? Can I steal 3 minutes? Motors Incorporated manufacture cars with 5 different bodies, 4 different interior, 6 exterior as indicated. So we have that. The interior color of the car cannot be the same as the exterior. So we need to deal with those restrictions. The interior, which means if I have a blue, I cannot have a blue. Okay. Motors Incorporated want to display one of each possible variations of its cars in their showroom. The showroom has a floor space of 500 meters square. And each car requires a space of 5 meters squares. Is this display possible? Look, let's start like this. Before you start counting, how many cars can they display? 100. Do we agree that they can display 100 cars? Do you know how we got the 100 cars? Number of cars that can be displayed. Number of cars will be 500? Okay, so this is the maximum cars that can be displayed. But according to this, can we get 100? Now that's where your job comes in. You count for me quickly, and then we call it a day. How many cars will this thing allow them? If the number is greater than 100, then they cannot. If it's less than 100, then they can. 5 different body types? It's exactly. You sure? Okay, you're too fast. And let's see.
Yes, I also got 100.
You got 100?
Yes, on the dot.
On the dot? Okay. Who else got 100 on the dot? What are you guys doing? Can you please, somebody take me through? Shamil, come, talk to me. What did you say?
So you have 5 body pairs.
Yeah.
So 5 would be your first number.
Okay.
Times the interior color would be 4. And then if you have 1, you can't have the same on the other. So you minus 1 from the total amount of the exterior. So that will give you 5.
Okay, does anybody have a different answer? Let's finish.
But gray and black, there's no gray and black exterior color. Yeah, there's only blue and red that matches.
You've got to look at that. You've got to look at interior don't run on this thing. You got to be, there's always a catch. Especially when you see something like this. 5 body types, I agree. Okay. You know what I would do? Since it's a mess, I'll do them differently. In terms of, look at blue. Guys, if I have a blue here.
Sir, could you calculate this halfway? And if it's greater than 100, you automatically say no.
Yeah, but you have to show that 100 first then. Okay, guys, if I have a blue, hold on. If I choose a blue here, then I'll have what? 1, 2, 3, 4, 5. Let's try to, don't run. I know it's interesting now. It looks, this one is easy. Blah, 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 blah. Let's be calm about it. Look at this. Okay, 5 body types remain constant. Okay, let's choose a blue color. If I choose a blue interior, I'll have 5 body types. I'm having a blue. How many interiors will I have? 5.
5, yes.
And that gives me 25. Make sense? By the way, let's go to a gray. How many body types? 5. I have a gray color. How many? 6. That gives me a 30. Next one, I have a black. I have 5 body types. I have 1 black interior. I have 6 again. Then I have a red interior. What do I have? 5 red interior. How many exterior? 5, because red is also present there. What will this give me? 30, 60, 50, 110. So answer is no. Maximum display is 100. Talk to me, let's finish.
Oh, okay, I see my mistake.
You see?
Yeah.
So I'm going to advise us to count. It's easier to count. Easier to count. That's why, you see, I dropped formulas when we started looking at activities now, right? So counting. Did it make sense? We need to shut up now. Anybody? Yeah, these are the MBTs should love these ones more. Okay. Have a lovely evening, everybody. Somebody asked me if where to rewatch this. Okay, I'll send the link. Usually the link is for registered kids, but I'll send it to everyone for a rewatch. Okay, so that everyone can rewatch. If you're not on the group, make sure you get on the group 0817442103. Send a WhatsApp. Who asked me that question? Let me see. Yes, guys, we are done. You may.
Goodbye, Mr. Bishop.
Bye. Bye. Calvin, are you on the group? All right, guys, bye. Calvin, are you on the group? Bye, Sabiha as well. Yes, so Calvin, you'll get it. And also you get a rating. Please rate us 5-star or 10-star if possible. Good night, everybody.